All right, Geometry A students, we're going to do a little bit of review here with similar triangles. So for me, the idea of similar triangles is when you zoom in or you zoom out of a triangle. So some things change. Some things change when you zoom in or zoom out in the triangle. Some things stay the same. So if you haven't yet thought about number 1 and number 2, think to yourself, when you zoom in or zoom out of the triangle, what are the things that change in the triangle? When you zoom in or zoom out, what are the things that stay the same? I encourage you to pause the video, think about that. All right, but here we go. So things that change, to me, kind of obviously are the side lengths. Side lengths change, side lengths get bigger or smaller as you zoom in or zoom out. But what doesn't change, what things that stay the same, the angles do not change. That's one thing that stays the same when you zoom in or zoom out. You don't change the angle sizes. But the other thing that does not change is the side length ratios. The comparison of side lengths is another thing that doesn't change. Okay. So when you're ready, you can take a look at number 3 here. So number 3 says Kevin took triangle ABC and zoomed into it to create triangle KSM. But he also spun the triangle around and possibly flipped it over. This can make it difficult to track where the sides went. We have measurements for the triangle, and then we're going to fill in the blanks. And I realize we got the little image of me in the bottom right corner, so let me scroll up here in a moment. But see what you can do. Fill in the dimensions. See if you can fill in the table here, and then see if you can solve for the side length or the length of side KM. Okay, so I've got everything labeled on the diagram that I was told, and I also figured out angle C is 32 degrees. I was not told that, but I used the good old triangle angle sum. If I know 2 angles in a triangle, I can figure out the third angle. And similarly, angle S, I was not told the measure of angle S, but knowing angle K and angle M, that's 2 angles in a triangle, I can figure out angle S is 43 degrees. So so what happens if we take that small triangle at the top, if we zoom in, if it gets spun around, maybe flipped, where does AB go? AB becomes which side? If you haven't thought about it here, the idea is that side AB, maybe I do this in green. Well, the angles help to guide me. Since the angles don't change, I can say, well, AB was opposite from 32 degrees. So in the other triangle, what's opposite the 32 degree angle? The 24. So side MS. AB becomes side MS because they are opposite. They are both opposite. I'm going to say OPP for opposite the 32 degree angle. So those are what we would call corresponding sides. What about BC? Where does BC end up? So here's BC. It's the bottom side of the original triangle, but we zoom in, we spin it around, flip it over, etc. So how can I track where BC went? What BC became? I look at the opposite angle. We got 105 degrees opposite there. So that became the side KS or SK. So those are both opposite 105 degrees. At this point, you might think, oh, okay, so obviously it's just going to be AC is going to become MK or KM by process of elimination. But let's just convince ourselves here. AC is opposite from a 43 degree angle. And let's see, opposite 43 degrees here is KM. All right, so just in case if we had a mistake somewhere else there. So those are both opposite 43 degree angles. All right, so again, what we call corresponding sides there. So now, if you haven't yet, take a moment, pause the video if you need to, and see if you can figure out what's the length of KM. So one thing I've also done that might help you is I filled in the measurements that I know into the table. So I squeezed in the 5.9 next to where I have side AB, and I squeezed in the 24 next to MS, etc. So how this helps me is to say, well, I can create a proportion here. Since I don't know and I don't care about KS, I don't know or care about KS. I can ignore this entire row. I could figure out KS, but I'm not asked for it. So essentially, I've got the top row. I'm going to take the numbers here, and I've got the bottom row, and I can set up a proportion. So I can say 5.9 over 4.6 is equal to 24 over however you want to represent that. We do not know side KM. And now I've got a proportion. I can just cross multiply and divide. I don't know that this is going to work out nicely, but multiply diagonally, 4.6 times 24, divide by the third number, and what does that come out to? I got to punch it into the calculator here because I don't have a cheat sheet right now. I come up with, it's about 18.7. It was on the calculator, it was 18.7118. Didn't have rounding instructions. I'm just going to go to the nearest tenth. So 18.7, that 7's got a 1 next to it. So there you go. So that's it. So the corresponding sides help me create the proportion. I knew the corresponding sides. AB corresponds to MS because they're opposite the same angle. BC corresponds to KS because they're opposite the same angle. AC corresponds to KM because they're opposite the same angle. So hopefully that video helped. See me in the next one.